Good afternoon. Thank you for the introduction. Today the presentation is about the Heinrich Schliemann Archive, only focusing on the copy letters. So Heinrich Ernst Schliemann was born in 1822 in Germany. Schliemann had an inclination for languages, and during his life he learned to speak fluently 12 languages, among them Greek, Arabic, and Turkish. As an independent tradesman, he accumulated his great personal fortune. In the following years, Schliemann started traveling around the world. During these travels, he always kept a diary, and it is from these diaries that we learn much about his life. In 1863, Schliemann decided to devote himself to his childhood love of ancient Greece. He enrolled in archaeology courses in Sorbonne, France, and absorbed by his passion for Homer and archaeology, spent the rest of his life on archaeological excavations, all of which he financed himself. The discovery of the ancient city of Troy was one of Schliemann's greatest accomplishments and brought him worldwide fame. The Schliemann Archive in the Gennadius Library in Athens, Greece, houses today most of the documentation belonging and related to Heinrich Schliemann. The Heinrich Schliemann Archive consists of diaries, correspondence, original letters, copybooks of letters, newspaper clippings, and many other. The 43 volumes of Schliemann's archive cover a period of time from 1845 until 1890, and they offer a wide variety of different copy techniques and materials, as he showed particular interest in the technological developments. From 1845 until 1868, Schliemann copied his letters using loose sheets of copy paper, and he accumulated them until they were enough to be bound as books. From 1869 until 1890, he used commercial copy letter books. Originally, there were more copybooks, but some of these volumes were lost during the Second World War. The aim of the study was to employ non-destructive techniques in order to document the copybooks and loose copy letters, and to record the behavior of inks in the non-visible regions of the spectrum as a critical clue towards the documentation of the preservation state and the differentiation of the types of ink. The methodology is based mainly on the use of non-destructive imaging techniques, as it is not always easy to obtain samples from inks and manuscripts because of the historic value of the archive. The applied methodology included the following stages: photographing the outer body and pages of the books in the visible, photographing selected pages in total detail and macro mode, recto and verso, digitization of the photographic material, comparison of the image information and process of data, results on the state of preservation and categorization of inks. In the beginning, a survey based on optical observation was carried out through the entire archive of copybooks. This step was very important as it determined the choice of the most characteristic pages on which the non-destructive examination would be applied. Special care was taken so that the selection of pages was representative of the different types of inks. Another important consideration for this selection was the fact that the earlier books, many and different types of copies were found, because loose documents had been bound together to form volumes. The other volumes were bound from the beginning, and the letters were put in them for the production of a copy. Some of the volumes were in poor conditions, preventing any handling, let alone photographing them. Other volumes were very big in size, making it difficult to photograph them and dangerous for the object itself when attempting to flatten the pages. Volumes 28 to 43 comprise pen letter books, which presented similar behavior, so only 4 representative examples from there were chosen. All non-destructive diagnostic techniques were applied in situ in the Gennadius library. The instrumentation was transferred from the Technological Educational Institute of Athens to the archives section in the Gennadius library. For the different needs of each photographic technique, the archives room was properly arranged and an adjacent dark room was used. As this research was carried out years ago, the available means were only analog. Therefore, for visible photography, UVR, UVF, and UVFC, bracketing was considered essential in order to locate the appropriate photographic conditions. In the end, after the development and digitization of the film, the photograph showing the best and most useful results was chosen. The black and white negative films that were used for UVR and UVF were developed by the researcher using the appropriate chemicals and controlled conditions. Color slide films used for the visible and UVFC were given to a specialized photographic shop to develop. The covers of the copybooks are in a rather good state, with only a few cases to present damages at the spine and the covers. Huge volumes exhibit loss of their covers and spines. Tears along the joint of the cover and the spine have been observed, as well as detachment of one or both covers. The cover material, in example leather, paper, or textile, is usually damaged at edges, and in few cases it is torn. The text block presents limited creases, water stains, paper losses of small extent, and rarely holes and tears. In few cases, it was detached from the binding. Other damages regard the iron gall ink corrosion, so lacing, discoloration, embrittlement, fragility was observed, resulting in breaking of the paper support and losses. Regarding Schliemann's copies, they can be characterized as of excellent quality that cannot be distinguished from the original handwriting, very good quality, clear with satisfying distinctness, poor quality, faint and indiscernible, and bad quality comprising blurred and illegible letters with continuous writing without gaps between the characters. In most cases, entirely good or bad quality copies were not observed, but they rather present combination of copy qualities. Even in one page, differences of the copy quality could be observed. The thickness of the writing of letters, the distinctiveness and readability of copies usually depend on the methodology of the copy, for example, humid or dry method, on the quality of the writing ink of the original, on the materials of the copy, for example, ink and paper, and on the application of the method. In most cases, the way of application was responsible for the result. Bad and hard to distinguish copies result from the application of limited amount of humidity or insufficient pressure, so the ink is not properly activated and it presents ineffectiveness in imprinting the copy paper. Hard-to-read copies result when excessive or uneven humidity is applied, causing the intense diffusion of the ink, which unifies letters and words. Even though Schliemann was a systematic copier, he was particularly hasty, so the quality of his copies is in many cases poor, not because of the materials, but because of the careless application of the method. From 1869, Schliemann uses the pen letter book type of copybooks, a product for copying without the use of humidity, according to instructions found on the front end leaves. With the presumption that the instructions of use have been followed, the copies that result are of moderate quality, as the ink presents particular diffusion, the writing is thick, and the text is not particularly distinct. Discoloration is observed only at copied areas. A general observation concerning all ultraviolet reflectance photography images is that they are very dark gray and the inks are all black. UVR images of inks, due to their high contrast, enable the definition of the boundary of the ink rather than that of the letter. This means that if a letter has diffused, presenting a diffusion halo around it, the UVR image will show the character and the diffusion together as a black image, while in the visible the character is clearly differentiated from the diffusion. Oxidation can be observed separately. In ultraviolet fluorescence photography, copy inks exhibit different tones of gray, from pale to dark gray, but never black. Diffusion halos can be differentiated from the main body of the letters as they appear in a lighter tone of gray than the character. Ultraviolet fluorescence color photography can be very useful as it can help in differentiating inks from one another. This is possible because when stimulated by ultraviolet light, the core of the letter fluoresces with a different color. The diffusion of a letter can be distinguished from the core of the letter as it usually exhibits either a different color from the core or a lighter version of the same color of the core. The behavior of the copy inks in the infrared differs little. The ink's black and white images vary from almost transparent, light gray to medium gray tones. A fascinating aspect of IR images is that they can show clearly the circumference of the core of the letter. Diffusion halos can generally be visible, but only as a blur without concrete boundaries. As false color infrared combines wavelengths from both the visible and the infrared, the information obtained with this method refers to both visible and infrared regions. In some cases of illegible letters, due to diffusion, the core of the letter can be distinguished more easily. Most of the false color of the inks are reddish or brown-red, thus discrimination of inks is very difficult. And this one is one of my favorite inks from all copybooks from the Heinrich Schliemann Archive. This is one of the most complicated inks that we have come across because in the visible you can see that you can actually find the core of the letters, the core of the character of each letter, but there are two stages of diffusion and then there is an oxidation halo around them. So in this case, in infrared reflectography, the body of the letter appears clearly with a slight diffusion halo around it. False color infrared imaging presents brownish coloration, the diffusion halo and the oxidation halo around them. In UVR photography, the letters appear very dark and are embodied to the diffusion halo, so that between them no separation is possible. But nevertheless, the method helps in the distinction of the oxidation limits due to high contrast. UVF and UVFC show clearly and more intensely the separate boundaries of diffusion and oxidation halos, with the second method giving also information on the ink due to the color of the fluorescence. So by using non-destructive imaging techniques, this research recorded the condition of Heinrich Schliemann's copybooks archive. The application of the non-destructive techniques helped in the closer examination of the inks used and can be of assistance in recording and distinguishing single characters, thus rendering the words of text more legible, as well as to better understand the phenomenon of oxidation or diffusion responsible for the halos. And I would like to thank Pinelope Banu, Angeliki Stasinou, and Katerina Gerakari, and also Mrs. Kaliga and Dr. Natalia Vokeiko from the Gennadius Library. And of course, thank you all for your attention, and vielen Dank.